Okay, so this is my video project for General Chemistry 1. It's going to be about stoichiometry, which is chapter 8. And more specifically, it's going to be about limiting reactants. And the question is, what mass of iron in grams could be formed from 113 grams aluminum and 279 grams of iron oxide? So I put a visual representation of the reactions. So remember that the left of the arrow are the reactants, so the aluminum and iron oxide, and then the right are the products, so whatever that is, and iron. I also put that we have 113 grams of aluminum, 279 grams of iron oxide, and we're going to be finding out how many grams we can produce with each of these substances. I got a pointer now. Okay. So solving the problem. So the best way to start these questions is starting with what we know. So we know that there is 113 grams of aluminum, and we can get that to moles. So we can convert grams into molar mass, and molar mass is the atomic weight. So you can find on a periodic table that the atomic weight of aluminum would be 26.98 grams. That means for every mole of aluminum, it would weigh 26.98 grams. Now that we have moles of aluminum, we can put that into the next fraction at the bottom. Why do we have 2 moles of aluminum at the bottom? Well, you can go back to the reaction and see that we have 2 moles of aluminum here, and for every 2 moles of aluminum, there's going to be 2 moles of iron. So that's how we got from 1 mole of aluminum to 2 moles of aluminum on the bottom. So we have 2 moles on the bottom and then 2 moles of iron at the top. And now that we have moles of iron, we can put that at the bottom and have for every 1 mole of iron, that would equate to 55.85 grams of iron. You do not need to do any math here. This is, again, just the atomic weight of iron. It's simply saying that if you were to have 1 mole of iron, it would weigh 55.85 grams. Now, as we're putting things on the bottom here, like the grams, the moles, we can cross these out. So you see on the left here, we have grams of aluminum and grams of aluminum. We can cross these out. For this conversion, we have 1 mole of aluminum and 2 moles of aluminum. We can cross out the moles here and here. Same thing for this, the moles of iron and the moles of iron. We can cross that out. And that leaves us with the unit grams, which is perfect because our answer needs to be in grams, which it is. So to get 234, you would simply multiply across the top. So you'd have 113 grams times 2 times 55.85. Then you would divide anything that's on the bottom. So you would divide by 26.98 and again divided by 2, and you'd end up with 234 grams. But that's just for aluminum. We also need to find out the answer for iron oxide. So we start with what we know again. We know that we have 279 grams of iron oxide. We can convert this into molar mass. It is a bit different from how we did it with aluminum because there's more than one element and more than one of each. So you'd find the atomic weight of iron and multiply it by 2 because there's 2 irons in this. And then you do the same thing with oxygen. So you'd multiply the atomic weight of oxygen by 3 and then add it to the atomic weights of both irons. And you'd find that the molar mass of this is 159.70 grams. And that would mean that we have 1 mole of iron oxide. It's simply saying that 1 mole of iron oxide weighs this much in grams. So now that we have iron oxide in mole units, we can put that at the bottom. So now we have 1 mole of iron oxide means that there's 2 moles of iron. We can see it again if we go back to the equation. There's 1 mole of iron oxide on the reactant side, and then 2 moles of iron here. That's how we get 2 over 1. 2 over 1. So now that we have iron in terms of moles, we can put that again at the bottom and find that 1 mole of iron equates to 55.85 grams. This is the molar mass of iron. This is how we get 55.85. So then we can cross out grams, moles, again, moles, and multiply everything on the top. So 279 grams times 2 times 55.85 divided by 159.7, and then that would equate to 195 grams of iron. So which one is correct? We have two answers, and they're both in grams, but which one is correct? It would have to be 195 grams of iron, because it is smaller than 234. It needs to be the smaller answer because iron oxide would be considered the limiting reactant. That means it runs out first. If you were to say that 234 grams of iron is correct, you are forgetting that iron oxide would run out before it achieves this amount of iron. It could only be 195 because iron oxide is still present before going over 195. That's why it would have to be 195. I think that's it. 195 would be the theoretical yield, I guess, if you want to add that, but that's not really important. And that's it. I hope you learned something.